So thank you for having me. And as I have said, I'm Yves Kalume. I'm an Android developer and a GDE. I'm from Congo. So that will be my first time to make a technical talk in English. But I'm very excited to share with you about memory leaks on Android. So before I try to share my journey with tech communities, I started involving in tech communities since 2019, and two 2 years later, I became a Google Developer Student Club lead in my university, and so I was like I always like to share with others what's my passion for tech, and after 1 years, so in 2022, I also joined the Google Developer Group organizer team, and I'm co-organizer of the GDG Lubumbashi here in DRC, and in April of this year, I became a Google Developer Expert for Android. And from that, I also like to make tech for social impact. So with, for example, DevCast, which is a tech community I co-found with friends of mine, and I also have some implication in other communities such as Soracert, which is an organization from here in Lubumbashi to help people starting in tech by providing them certification and also some mentorship. So the aim of this talk is to first explain some concepts related to memory leaks on Android, but also to make Android developers to think about memory management while they are creating their application. And memory management is the process of coordinating a computer's main memory. It involves allocating a block of memory to a running process in order to make it carry its operations. And since the memory on a computer is not unlimited, so we have to release this memory after it has been used and when it is no longer needed. And here is an example of memory management. We are just allocating some memory in order to store a int value in our program, and after we have used it, we just release this memory. And a memory leak is a kind of unintentional memory conception whereby a developer forgets, or sometimes a program didn't release a block of memory which is not semantically used in our application. And here is an example of a memory leak. So we have allocated some memory, but we didn't release it after it has been used. And on the GVM, we are not required to implement a memory management logic. And so we don't have a malloc or free to manage memory from our application. And we have a mechanism called garbage collector, which is a memory manager whose task is to free memory what it is not like semantically used in our application. And on the GVM, objects of our program are stored on the heap, and the heap also is not unlimited. So if the heap is full and you try to create a new object, it may throw an out of memory exception, an out of memory error, which means that there isn't any available space on the heap, but you try to create a new object, and that also means that the garbage collector didn't collect some garbage from our program. And as I said, a garbage collection is a kind of mechanism which is, well, you can say garbage collection is a memory management technique used in some programming language, and it automatically releases some memory, like while you are creating some, while you are allocating some block of memory on the heap, the garbage collector try to release this memory while it is no longer used in our application. So we are not required to implement a memory management logic in our application. And if we talk about memory in objects in memory and like garbage collection, we can think of it as this schema, and GC roots are just like objects which are referenced by the GVM, and they may also have reference of objects of from our program, and these objects may be called reachable objects since they are reachable from the GC root. And if a reachable object have a reference to another object, we can say that this other object is also reachable. And objects which are not reachable, we can say that are garbages, and they're eligible to garbage collection. So how does memory leak happen in Android? So I can say that memory leaks happen on Android when expected short-lived objects are attached to a long-lived one. And for example, we can have an object A, which is no longer semantically used by our application, but we hold a reference to this object in an object B. So we can say that A is leaked because the GC only collects objects it knows are not in use. And if you have a reference to another object from an object which is reachable, so the GC may think that this object is in use and won't be collected. And a common mistake we can see on Android is like people passing like activity or fragment reference to an object which live longer than this activity. For example, singleton and I can say global variables lives as long as our application is not killed. So if we pass a reference of an activity to an object or a singleton, so we can create a memory leak when the activity got destroyed, and the singleton will hold the reference to this activity, and the activity won't be garbage collected, and we can say that the activity is leaked. And one of the most important rules is that we should never keep a reference to an object that is not useful anymore in our program. So to solve this problem, we can just, like when the onDestroy method is called on our activity, we should just clear the reference to this activity from the singleton. So you can just pass the null value to the reference of the activity on the singleton. And memory leaks can be silent. This makes them like very difficult to detect in our application, but fortunately there are helpful tools to detect memory leaks in our application, such as the memory profiler from the Android Studio. You already have like a performance monitor, like a performance profiler of our application. But we also have some tools like Leak Canary, which is one of the most widely used tools for detecting memory leak in an application. And we have many other tools. But with Leak Canary, what I like the most is that you just have to install this library, and it will automatically detect the memory leak which may happen in our application. So the question may be, how does Leak Canary works? So that was one of the questions I was asking to myself for a long time, and I've tried to read and to inspect some code from the Leak Canary, and I will try to explain how does Leak Canary works. And the first step is to detect the retainer object. So we must have a circumstance or a case when we can say that an object is leaked. For example, an activity is leaked when it has been destroyed, but it is not garbage collected. So leak canary try to hook activities and fragment life cycles, and when the on the story method is called, it just sometimes it just like keep the reference to this object and wait few seconds in order to make sure that the garbage collection has happened. And if this activity hasn't been garbage collected, we can say that the activity may be retained or is potentially leaking. So here is a simplified code of how leak canary may operate. So just hook an activity like an activity life cycle, and when the on the story is called, we keep the reference to this activity, but this reference has to be a weak reference, because if we keep a reference to the activities, we will make it ineligible to the garbage collection. So fortunately in Kotlin we can have like a weak reference object, so we can just pass the reference of this activity to a list which may keep a reference to of all activity whose on this story has been called, and this reference should be weak in order to keep this activity eligible to garbage collection. And after that, so if we have like a certain amount of potentially leaking objects, so leak canary make what we call a heap dump. So a heap dump is just a kind of screenshot of our memory, and it just gets information about which objects are stored in our memory and which tip are there and how much data they are using on our memory. And it also contain information of where the reference to each object are being held in our code. And you should also know that heap dump may freeze your application while it's happening. So this is why leak canary used to show a kind of toast in our application where when it is dumping the heap. And we already have some API to make a heap dump in Kotlin or on Android. So we just call the dump hprof data and to the debug object, and we just pass the location to which the dump file will be saved. So when you make a heap dump and you get this file, you have to analyze it in order to know where our object may potentially be leaking. So a heap dump produce a file with extension .hprof, which is a binary file. So leak canary used to parse it use a library called shark. So when it parses the hprof file, it tries to locate all the retained objects which we have stored in our list, and it tries to find them in the heap dump. And after it has been found, they have been found. After these objects have been found, we must find the path of reference to this object in order to know from where these objects have been from where reference to this object have been held, and we can find a complete path starting from the root object from the GC roots to the object we are analyzing. And this is called a leak trace. So this is a kind of stack trace produced by leak canary. And here is a kind of example of how leak canary may operate. So it will just like make a heap dump and then using shark to analyze these files in order to find leak trace of our application. So after that, leak canary try to categorize leaks of our application, because they are application leaks which you have created and which you have to fix, and you also have library leaks which are not created by you. They may be in a third-party libraries you are using, and these leaks are impacting performance of your application, but fixing them may not be like in your in your control, so you have to deal with it, and you can also report these issues to the maintainer of this library. And one more thing you should know is that maybe your application is already leaking some memory, because there is a multitude of ways to create memory leaks in our application. So I couldn't show all code snippets which may produce memory leaks in an application. So you just have to pay attention, because it is quite difficult to notice memory leaks on modern system, because when on modern system, when an application are finished, the memory which was using is released, and sometimes in order to detect memory leaks in our application, we have to run our application on a very long time. So I can give you just some advices in order to try to fight memory leak. The first one is you should always pay attention when you are using reference to the activity, because this is one of the common mistake I've seen from Android developers as me. And sometimes we also pass the view reference to the something like a view model, and since the view model may live longer than the activity, so while the activity on the store will be called, this won't be garbage collected, because we have passed its reference to the view model, which lives longer than the activity. And another advice is like you should never you should don't forget and never forget to consult thread APIs and coroutine, especially if they are holding like reference of view. And I think you watch the talk from Ivan, I think. So he talks about structured concurrency, and this is one of the most important concepts related to coroutines, because a structured concurrency, the goal of structured concurrency is to make each routines launching from what we call a scope. And a scope is just you can say an object which the goal is to make sure that because in a real application you can launch many coroutines, and a scope is there to make sure that any of none of these coroutines are not leaking. And if you don't use structured concurrency, you should pay attention and make sure you cancel those coroutines while the parent scope, or you may have an error within them, because even coroutines are lightweight. They're also using some memory on our application, and leaking them is not a good idea. And another advice is to avoid to pass this to an object with which lives longer than this. As I was saying, like one of the most common mistake I've seen is that we usually pass this to, like, we can pass to log libraries, to some threads of computation, and sometimes we also pass this to view model, because but if this is a reference of an activity, should pay attention to pass it to an object which lives longer than this activity. But not only activity, but also any other object which has a short life cycle. And another advice is to usually use performance monitoring tools. So you can use the one from the Google Play console, which try to give you some insight of your application in production. And you can also use tools like Perfecto in order to track performance of your application. And fortunately, the Android Studio actually have a lot of tools which help us to monitor performance of our application while we are developing it. And you should also know that there are memory leak which you won't solve, you won't be able to solve, and you should not be obsessed by them, because sometimes you may be like uh, spending your time for and you won't solve it. But don't start to report them to the community, or to report them on something like issue trackers, on even on GitHub for some library. And I think that all for my talk. And thank you for your attention.
All right, all right. Great job, Yves. Wonderful talk. We're going to give the audience maybe a couple minutes to write their questions. If you just write them in the YouTube comment, then we'll display them on the screen.
Good.
Thank you. Yeah, so thank you very much. How do you feel the talk went?
So I think that was a quite good experience for me, because that was one of my first talk in English, and I think I didn't lost some people here. And
I mean, I find your English to be perfectly intelligible the whole way through. Like
thank you.
I have no issues understanding. Yeah, nice, nice. Man, diving into performance. It's a very interesting area. I feel like there are not many engineers doing it, and I feel like it maybe is a product of a lot of companies don't really invest in performance.
Yeah.
But like there are some apps that just I don't know. But I guess it depends on the scale of the application. Like
Yeah.
yeah, like older applications, like you're not going to just replace one oftentimes. Like you have to maintain it, and those ones make sense. There's going to be a lot of performance issues where maybe that's when companies invest more in performance infrastructure. Yeah. Nice. Okay, we'll give another minute for questions. How did you find out about Ender Worldwide?
So I was like scrolling on LinkedIn, and so I'm very passionate about tech communities. I'm on many, like I always try to find some opportunities from tech communities here in Congo. So I try to always to know how other communities are working, but also try to find some opportunity from people like from DevCast. And but I I usually find communities related to things like web development, open source, but this is one of the, I think, the biggest Android communities I've found. And I also find many people who I already know, because they are so important in the community. And that was so interesting. That is why I try to also be active in this community.
Mm.
Yeah.
Thank you very much. I mean, yeah, we're honored.